Hello, everyone. Today I'm going to talk about the PCA or Principal Component Analysis on the Sonar data again. Um, in the previous video, we run a logistic regression model trying to do the classification on the two types of materials in these sonar signals, and the results were not very good, and the accuracy only achieved around slightly more than one third the accuracy. So that's a very poor performance of the model. We're going to explore and these again to see the vectors or the variables in the data set. It has 60 variables, and so is that causes the kind of a noise to the model. So the regular logistic model cannot handle it in this space. So it's very curious. Maybe the PCA will give us some hints on this. From these results, we can find that there are some point, some variables like we can explain the data up to almost 80% around the 10 component, and we will room in and take a look and to see how this give us some hints on the future models we are going to build. Let's load the library where the data is stored. Take a look at the data, and we can see there are quite kind of a long or the wide columns, and we see it has 60 columns and the plus another one which is a label. That's what we are trying to predict as a class. R represents rock, and the M represents the uh, I believe it is metal, kind of two types of a material. Yeah, here is the metal M. So that's two kind of a classes in this data set. For the principal component analysis, in order to do the analysis, first we have to remove the label. It's like we're going to explore more and more the input variables, how it varies, or what potential of the hidden variations of the within these predictors. Um, let's remove the last column, which is the class label, and center it and scale it. Well, the biplot here, because of the so many columns, it's not very meaningful. But I can give you some ideas if it's fairly complex. Maybe it's a focus, or there is more variations and different directions, but it's hardly to tell which one will become dominant as at this point. Let's move on and to do a little bit more kind of exploration of the variations within these predictors, and trying to evaluate how much it varies in maybe in some space or in some dimensions. It causes the most variances. So that's the kind of a purposes of the principal component analysis. Then you can grab the most varied or most kind of most the features or the columns where the variations happens. So from this one, we can see as the proportion variation explained. The next one is more accumulative is more intuitive to understand. That means as we add more and more components, so the variations within the predictors, it's kind of it's a reach, it increases, but it reaches almost like a plateau after the 30 components. That means this component will not contribute to any significant variations within the features. So in that way, um, that means it's closer to the constant. If it does not vary as a predictor, how you're going to tell the difference um, in the label or in the touches we're trying to differentiate. So that's the main idea within this PCA. Hopefully, we can use less predictors or a fewer columns to redo and refine the other models. Thank you for watching this video. See you next time.